Hello, welcome to Aircraft Maintenance Practices Unit 8 lecture. This lesson, we will introduce bearing classification and its purposes, the nomenclature, bearing loads, and the types of roller bearing elements. Also, we will base on bearing life and calculate the bearing and select the appropriate bearing for the questions. Bearing, its purposes. Bearing is to support the shaft, that is to carry the loads for the machines or the systems. It is also to reduce friction so that the shaft can rotate and limits unwanted motion, locate axial movement. All right, axial movement. Axial movement is also known as a thrust load. So axial load is actually referring to thrust load also. So from here, we know that is to control the unnecessary movement of this direction and also to guide moving parts. That's bearing. So these two pictures illustrate well on friction. Okay, mu coefficient. So without any rolling elements, of course we will have problem pushing the crate or the parts that we want to move on the floor. So over the period of time, human invented and came up quite a number of design and prototypes to move heavy loads on the ground. So along the way, one of the good invention will be rolling bearings. All right. So this is a typical bearing classification. So there are magnetic type bearings, fluid firm bearing, and we will talk more about rolling elements as is one of what we are interested in, especially in aviation context. So rolling bearing itself is further classified into three types of bearing available: ball, roller, and needle. So the most two common bearing used in aviation will be ball and roller. Roller is further subdivided into three types available: cylindrical, taper, and barrel. So let's talk about rolling element bearing. These are the bearings with rolling elements: ball, cylindrical roller, taper roller, symmetrical barrel roller, asymmetrical, and last but not least, needle roller. So you have an outer race and an inner race in this case, okay, where the bearings are sandwiched in between that. Bearing nomenclature. So this slide talks about uh, terms for type of bearings. So we are outer race, the inner race, the cage, and in this case, the rolling element shown here is the ball and is a point of contact. So having said that, bearing come with either sealed or shield to prevent ingress of foreign particles or dirt as shown here. So bearings are pre-packed with its own lubrication particles, which is grease most of the time. Okay, and the shelf life or the working life of the grease is actually similar or end at the same time with the life of the bearing. So and it means in other words, throughout the working life of this bearing, they are it's maintenance free. It requires no greasing effort by the company. So this bearing is actually designed to use and throw. All right. So yeah, and not all bearings come with a cage. It can be in this case, if this setup with a cage is a fixed, okay, fixed point ball bearing. That means this ball bearing will actually rotate on the spot and to prevent axial movement. If there's no cage, then the ball rolling element itself is actually floating and able to move around and rotating. Okay, so that's just a design. Okay, this is another slide talk about the bearing nomenclature. So just to bring up one point here will be we are very keen on the small diameter, small d here, which is referred to as a bore diameter. All right, so it's either a bore diameter or it's a shaft diameter. Okay, so subsequent calculation selection of bearing, we will utilize the bore diameter quite often, while the d will referring to the outside diameter or the overall bearing diameter. Okay, so let's move on. Which can carry a higher radial load, assuming same size. Okay, so on the left hand side is a roller bearing, on the right hand side is a ball bearing. And radial load is referred to the load that is perpendicular to the shaft axis. Okay, if the shaft axis is horizontal, radial load is always at a vertical and perpendicular to the shaft axis. Right? So what do you think? A roller bearing or a ball bearing can carry a higher radial load. Of course, coming from the point that with more contact area, the roller bearing will definitely be able to carry a higher radial load as compared to a ball bearing of same size. So let's talk about bearing loads. Okay, most of the time there are two types of loadings we will encounter: radial load (FR), okay, given by FR radial load. So radial load is perpendicular to the shaft axis, all right, and the other one in blue arrow is called FA, is referring to axial load or thrust load. Okay, the thrust. So it's not perpendicular, no, it's parallel to the shaft. So it acts along the shaft axis. All right. So axial load. So when you combine together, then you have when you have both loading, right, you have to do a summation of all forces. But there's one table and chart for you to refer to in appendix to calculate the so-called the combined loading. All right. Bearing loads. Select bearing based on conditions. So when you have a radial load, the load is perpendicular to the shaft axis. When you have axial load, the load is parallel to shaft axis, and there's a combination of both loading, so resulting load at an angle to a shaft axis. So yeah, this is the typical loading we will encounter. It's either pure radial load, or you have axial load, or you have combination. All right. So this is a typical bearing load example. Chain drive, belt drive, spur gear drive. Okay, over here where there is a machinery driving through a chain, then the bearing itself here will experience a radial loading. Okay, same things for that, the belt. Okay, when you pull, you will experience a radial load, and for the shaft, the weight of that at the end of the pulley will actually create a radial load. Another example of bearing loading. Okay, we're talking about axle loading in this slide. So when you have the person weight onto the chair where it's spinning, so the weight of the person will actually act as a thrust load or axle load. Same thing goes to the drill gun. When you drill, you push towards the drill bit to cut the block, and you will introduce axle load onto the hand drill bearing. Alright, so that's another example of bearing installation on a shaft. Alright, some can be a tapered shaft, I'm making a parallel shaft. So this is a typical chassis, the wheel rim. So the radial load is actually referring to the weight of the car, and the thrust load or axle load is actually the correring force, right? So this picture also illustrates how the bearing was being held in place by a snap ring, okay, and retainer screw. So this is just another diagram to illustrate the installation of the housing of the bearing. So is this a thrust or axle load? If you were to recall, the loading based on these arrows, which is parallel to the axle of the shaft, all right? So this is actually a or an axle load, all right? So you look carefully, it's parallel with the axis of that. So yes, this is a horizontal axle load and this is a vertical axle load. All right, other than axle load or pure radial load, we also have a combination loading which keep repeating. And we mentioned earlier when we come to the question or example, then we will illustrate how do we calculate the combination loading of FA and FR. All right, this is a typical overview of a rolling element chart. So the rule of thumb is actually when it comes to what we learned and what we understand is cylindrical roller bearing. Okay, cylindrical roller bearing actually is capable of taking up radial load as compared to ball bearing, right? It can take slight axle load, depends on whether is there any rip. All right, under statement 3 here, there's a note here. Some cylindrical roller bearing with rib can bear an axle load. All right, some, not all. So for the ease of calculation and understanding all calculations when talking about roller bearings, right, we will only take the radial load into consideration while axle load will not be in the roller bearing calculation. Then if there's an axle loading, then you will need a ball bearing element as mentioned. Okay, ball bearing element will be able to take up both radial and axial load. All right, but when it comes to the loading size, roller bearing itself has a bit better capability to accept higher radial loading as compared to ball bearing. But ball bearing is more versatile because two of this loading, radial and axial, are able to work on the ball bearing. All right. So of course you have needle bearing, taper, self-aligned roller bearing, and truss ball bearing. So you look at it is the carrying capacities are shown here, right? So the next few slides will talk about individual ball bearing capability and characteristics. So a deep groove ball bearing as shown here, all right? So outer race, inner race, the ball bearing and the cage. So as shown here, ball bearing can accommodate radial and axial loads, right? So this is the plus point of ball bearing. Operate at high speeds, create a very low friction environment. And what do you mean by locating bearing? Okay, look, when you have a cage, it's known as a locating bearing. That means the ball bearings are not floating and is fixed at one position due to this cage. So it is this design prevents axial movement of the uh, roller ball bearing. Okay, and most of the time it comes with a seals or shoes to prevent ingress of FOD or dirt, right? Deep groove ball bearing, it has a very good radial load, moderate axial load, And this type of deep groove ball bearing, due to its curvature with the contact point, uh, it can operate at very high speed compared to a normal ball bearing. But the rest, it acts as quite similar to a ball bearing. Cylindrical roller bearing. As mentioned, it has a capability of taking up high radial loading. All right, good speed capability. Comes with inner and outer ring. All right, and cylindrical roller bearing. Um, if it comes with a rig design, like then some extra loading will be able to be absorbed by this bearing. But of course, when we come to calculation, all right, we only take roller bearing for radial load. So where is used at turbine engine main shaft transmission, gearbox application with high radial load condition. Tapered rollers. They are designed for heavy axle or radial loads in one direction. All right. So most of the time, taper rollers are found in the main and nose landing gear. Right. Spherical roller bearing is a preferred choice when conditions include heavy radial loads and difficulties with housing alignment or shaft deflection. All right. So if you have a condition where there's axle loading only, then it's not recommended to use spherical roller bearing. Fast speed capability. It can take misalignment up to 1.5 degree as shown here with no loss in capacity. All right, 1.5 degree. So normally it's 2 row. All right, so it's used at a main reduction gear transmission for helicopter main rotor drive, or can be a turbo propeller gas turbine engine. All right. Needle bearings, excellent in radial loads, but very poor in axle or thrust loading. It is used where space is limited, ability to support high vibratory loads, and is compact. So where space is a premium. All right, we have come to bearing numbering systems. You have to know this because subsequently you have to use the numbers to read the chart or the appendix. So bearing designations indicating the type, series, and bore. Bore of a bearing. So what does a bore represent? Bore is actually the inner diameter, where also known as the shaft diameter. All right. Built up by a combination of the above code number or letter in sequence. So bearing number 6210, what does 6210 represent? 6 represent the type of bearing. So in this case, number 6 refer to deep groove ball bearing. Okay, 2 is a series code where the type of ability the bearing loading able to take up light duty, and 10 is actually the bore diameter. Okay, bore diameter. So we will move further down to explain all this. All right. So bearing series, what do you mean by that? Of course, this is a same diameter shaft, and you have various size of the bearing. Okay, but they are the same bore diameter. So this is the bore diameter. It's actually in fact the shaft diameter. So 6005 refer to extra light series. 6 refer to deep groove ball bearing. All these 3 bearings are deep groove ball bearing 6 series, where 0, 2, 3 represent the types of loading condition. Okay, light, extra light, light or medium loading series. All right, and 5 is actually referring to the diameter 25. There's a type of calculation you need to know later. I think further down the slides we'll talk about how we obtain from the last 2 digits and determine the shaft diameter. On the right side, they maintain the same outside diameter. All right, you can look at it. The outside diameter is the same. Okay. But the ball diameter varies. Okay. So then again, there'll be slightly different. Okay. Your last two digit will be different. Okay. It won't be 0.5. So it depends on what is the shaft or the ball diameter you use, but it will be the same as 6 series. 60. Okay, but we do not know the last two digit. This 6205, 62, sorry, 62. We do not know the last two digit. It's not 05 definitely, unless it's of course the same diameter. Then of course this is 63. Okay, so let's move on. What do you mean by the 3 and so this is the chart given by the manufacturer. Do take note, okay, the series code here. This is referred to ball bearing. This is roller bearing. So please don't jump the gun. Make sure you read correctly the headers. If you are now working on ball bearing, in this case earlier, so you see there's a 9. It's referring to extremely light. Okay, extra light, light, medium, heavy. So these are the type of loading condition you will select on the bearing. So if you are using on a heavy industry environment where you know that the operating load is high, then you may want to use a 4 series. Okay, if let's say example you just want to use as a conveyor belt series, maybe extra light or light series. Of course, what is the difference? The majority vast difference of that would be the cost of manufacturing of the type of bearing. The heavier loading the bearing can take up, the more expensive it is. The same thing like iPhone. Okay, you want it to be able to have a better camera capacity, better display, better speed, then there goes the cost. So roller bearings represent 1910234. So you can see, okay, let's move on. So we talk about the last two digit. The last two digit represent the ball diameter. Okay, 2 digits define the diameter of the ball in millimeter. Okay, so for ball diameter below 20, the code number are shown below. So if it's 6, let's say 6900, 6 represent deep groove ball bearing, or 9 represent extremely light duty, 00 will represent 10 mm. If it's 6901, then 01 itself represent 12 mm. 2 represent 15 mm, 3 represent 17 mm of the ball. Okay, so this is for anything from 0 to 3. But if you have a bearing code number of 04, example 6904 or 6104, example, then any number you will multiply it by 5. Okay, I say again, 0, 0, 0, 3, 0, 1, 0, 2, 0, sorry, I repeat again, 0, 0, 0, 1, 0, 2, 0, 3 is a direct reading. So you need to read directly is 10, 12, 15, 17 ball diameter. But anything that is last two digit, which is more than 4, 04, 05, all the way to 09 or 10, then you just need to multiply 5 to get the ball diameter. Okay, the more you practice, the more you understand what I'm trying to say. Okay, we're coming to the end of the slide. This is a typical how you will want to mount your bearings. Of course, it's always interference fit onto or transition fit type of bearing to the shaft. And after that, to hold it in place, you will actually have a retaining ring, a circlip. Okay, something look like this, a circlip to hold the bearing in place to prevent you from moving off the position, or you actually have a lock nut. Okay, although you have a lock nut, then your shaft is actually must be threaded, and then followed by a lock washer to prevent the nut from coming loose. Yeah, so this is a typical attachment exploded viewed. So the bearing actually will be fitted inside onto the sleeve here. So it's a tapered. So when you fit the bearing and you install the lock washer and you tighten the lock nut. So under this type of installation, most of the time the manual will ask you to set the first torque will be very high, maybe example 500 inch-pound. Then ask you the first torque 500 inch-pound is actually to sit this bearing onto the slit. Then the manual will actually in fact ask you to loosen it and tighten the lock nut at a lower torque value, which is maybe about 200 inch-pound to 300 inch-pound. So it's just a number. So the first torque is actually a force applied onto it to sit this bearing onto the adapter sleeve. Okay, so this is typically what we will do for installation of bearing. All right, we come to the end of introduction of bearing lessons. So the next one we will talk about bearing selection, which is actually some example we will use to calculate and select the bearing required.